My name's George Cummins. I'm one of the directors at Gait and Motion Technology. I stand just over there. If any of you sat through yesterday's workshop and you're still here again, it will be the same workshop. So you can either sit here and listen to it again or go mad and get a cup of coffee next door. So I'm really going to go through a presentation called The Future Is Now, Footscan and Phits 3D printed orthotics to talk about the clinical applications of this solution, how it's very new, perhaps a very different way of doing things that you might have been used to, particularly if you've been in podiatry or orthotics for a very long time. Very brief overview about Gait and Motion Technology. We specialize in cutting-edge biomechanics solutions, ranging from small inertial sensors, joint measuring devices, all the way up to full natively integrated gait laboratories. So, as an example, just down the road, Alderhay Children's Hospital have a huge gait laboratory. We've got force plates, EMG, cameras, and it's a really nice setting for the really kind of high-end gait analysis. We've got a few international partners. We're a partner of RS Scan, obviously the pressure measurement company. We also work with BTS Bioengineering, who are an Italian-based company, and Meloc, which are from Sweden. And we're based down in Cambridge, so we cover the whole of the UK. Last point, I probably should mention that as well. We've got a unique clinical support service. We actually have a team of podiatrists and orthotists as part of the company, which is really valuable because we're able to actually provide full clinical support and training to all of our new clients that we support. And that's really useful. You can discuss particular patients, and that's all something that we provide under Gait and Motion Technology. Brief overview of Footscan. Many of you might be aware of Footscan. I know we've got a few guys sitting down right now that have RS Scan in their clinic. It's a pressure measurement system that has lots of nice clinical applications. It's not just about gait analysis. We can look at all sorts of different movements, which I'll get onto. It's a plug-and-play system into your laptop. If any of you are really interested and would like to actually have an assessment yourself or come and see the data that you can get and the clinical applications, we've got a system out over there. More than happy to take anyone through it afterwards. Okay, just going to talk about objective and clinical outcome measures. So obviously in terms of gait analysis, there's lots of different forms of this, whether it's treadmill, whether it's visually looking at someone walk through the corridor down your clinic. But obviously these particular aspects are quite qualitative, so we're really just visually analysing and trying to explain what's going on, which is sometimes quite hard with patients if we've got no data or objective measures. So to have quantitative information where we can accurately show a patient, this is you, this is what's going on beneath your left foot, beneath your right foot, here's the asymmetries, here's the load, it's very, very useful, and particularly looking at comparisons over time to be able to see a patient today in 12 months' time, particularly in that risk population like a diabetic, is really, really useful to see change and actually make a change before it becomes a severe problem. So we're all about evidence-based practice. The more information and data that we can capture, which is easy to put across to the patient, the better. And again, a really nice thing, which is actually really important. I know Dave touched on this morning, but it's about the patient experience. How can you really enhance the service that you can provide to your patients? If you can provide them something visual, this is you, here's your report, it really adds a lot of value, particularly if you're charging for a gait analysis, for instance. So a few different outside of the gait clinical applications that we can use. So this is a static snapshot of me standing. So we can see for myself, that pink cross is my center of pressure. You might not look at me visually and realize this, but nearly 2/3 of my weight goes through my right side when I stand still. I've got a slight curvature of my spine, which my colleague bullies me for. But we can see, particularly through my right heel, I have a lot of pressure. Over 40% of my weight goes through my right heel statically. So to be able to get these measures is quite useful for an initial snapshot to see how does that individual stand. We've also got lots of functional movement applications, so we can assess someone's balance, whether that's statically, whether that's on their left leg, their right leg, or if we actually want to do a more functional movement screen. So as an example, this is me doing squats over a 20-second period. So ideally, when we're doing a functional movement, ideally we'd like to see equal force through the left and right side. I'm not going to do a squat right now because my trousers are quite tight and that would be really embarrassing. But from this example, we can see I clearly put much more force from my right side every time. So there could be a number of different reasons for this, but again, to be able to objectify and highlight that asymmetry is really powerful. From a clinical application, they could be coming back from an injury, or actually just their biomechanics in general doesn't allow them to do that. So as an initial snapshot of a movement, to be able to use this and as part of the rehabilitation process, assess a gain in future, you've got evidence, you've got outcomes to show, okay, things are going in the right direction, and it allows you to kind of give a bit more scientific basis to what you're saying to patients. Okay, bit of an overview on traditional orthotic manufacturing methods. I'm sure most people in the room will be well aware of these. So most commonly, static foam boxes and casting. Been around for many, many years. Absolutely not a negative, because it's the way that it's been done and it's the way many of us have been trained. So we're able to capture the shape of someone's foot statically, which absolutely has a place, but we're really thinking about how can we do more? How can we assess the foot dynamically and understand exactly what's going on when the foot's moving? Because that's the shape of my foot statically. As soon as it hits the floor, it changes, particularly when we run. And how can we account for that in terms of an orthotic? As we know, it's slightly time consuming, it can be messy. So from a clinical perspective, if we can minimize these time implications, time is money and time is more time you could be spent focusing with the patient on other care. There's quite an interesting article in Podiatry Today. There's a little reference at the bottom, and it's discussing about traditional orthotic labs and some of the compromises that go on in that process. So things like generic prescriptions, which slightly restrict you, custom made versus custom molded. Is it literally just the shape of someone's foot, or are we starting to put in more modifications in that process and take more into account in that design? Many companies as well, and I've worked in traditional orthotic labs in the past, have quite a limited library template of shells, so kind of restricts you. It's not as bespoke as it can be for that individual. Obviously very poor casting techniques in some cases, not necessarily poor, but in terms of reproducibility, we used to receive 100 plus foam boxes a day, and just the different techniques of how different people do it, it makes it very hard to make it reproducible, particularly if only the toes have just lightly been dipped in. It's very hard to make an orthotic from. Mirroring left and right, again, this is something we really push. If we're providing an orthotic to someone, it's really important to have it specific to the left and specific to the right. And that might sound silly, but in lots of cases, particularly if we're visually analysing someone, it's very hard to see those minor asymmetries beneath the left and right foot. So if we can now start to accommodate that within the device, we can start to correct those biomechanics even better. Last point I'll have down, whether it's on your agenda or not, it's becoming increasingly in the public awareness at the moment, but it's about the environmental wastage. So thousands and thousands of foam boxes are being burned, and also CAD/CAM waste. So the nice thing about how things are changing is we're looking to totally eradicate all waste, which might not mean a great deal to you, but on a global scale, it can make a really big difference. Okay, so in terms of static and dynamic, I initially touched on this at the start. For us as a company, we like our clients to talk about what we do and the message that we push. For the clinician, it's your decision on how you prescribe, what your methods are, but here's just a brief paragraph in terms of the opinion of one of our clients who's an orthotist. She was one of the first clinics in the UK to introduce dynamic 3D print technology. Had great success over the last 18 months, and really highlighting the importance of capturing that data. So when we're looking at the feet, particularly if someone's running, for instance, the foot's in contact with the ground for such a short space of time, really we want to get as much data as we can to understand what's going on. So to be able to record at 500 frames a second, our eye simply can't compete. Again, I'm not going to read that out. Hopefully that's given you enough time. So I will move on through there. So dynamic 3D print technology, how is this different and how is this new? So Phits as a brand, I guess, the world's first 3D printed orthotics, which is specifically designed on dynamic gait analysis. So we're now able to utilize the data that we've collected for that individual and translate it into a device. It's a very intuitive software that actually will take that data and do parts of this design for you. It's a suggestion. It will say, based on that data, this is the best stiffness direction for that individual, for instance. And you have complete control over this as a clinician. You've not got to go, okay, I'll settle with that. it's your decision. There's over 8 million options that we offer in Phits. And that's not to make it sound complicated, it's because we can literally cater for any footwear, any condition. So there's lots of types of 3D printing. The one most people are aware of is called FDM, and it's where you have a 3D printer that layers and layers and layers to build up an object. So for an ornament or something like a cup, for instance, great, we've got an object. But for a foot orthotic, where we've got shearing forces, it would literally break along the ridges. It's very brittle. So we need something that is far more robust. So we use a process called selective laser sintering. So these are extremely durable orthotics. To date, since launching, we've printed over 3,000 pairs since March last year. We've had 0 breakages, which is a testament to the strength of the material. At the same time, it's also very flexible as well. So it's giving you that best of both worlds. Really nice part is they're really lightweight, so they're less than half the weight of traditional orthotics. And if anyone would like to come and hold one, for instance, we've got a few samples on the stand, come and have a look and you'll be impressed at how light they are. Intrinsic modifications, again, we see it as a strength. All of the modifications are built into the device, so there's not someone in a lab manually sticking on a metatarsal dome or grinding a 2-degree heel wedge by eye, for instance, which again, absolutely no problem with that. But if we really want that top accuracy and repeatability, there is 0 room for error in 3D print manufacturing. What you order is exactly what you get, to the nearest 0.1 millimeters. We've got a range of different top cover options. Some of you might be familiar with a material called D3O, which is like an orangey material. You might have seen a big tub of goo in the past, which allows you to demonstrate the properties. But in short, it's the leading impact protection material. So when it's under the foot, it's absolutely spot on for its application, but it's also very durable. Where things like EVA will start to flatten or bottom out over 3 to 6 months perhaps, D3O will completely keep its shape for at least 2 years. Also very popular in the diabetic world as a material. There is another company just the other side who provide D3O as a ready-to-wear device. And there's lots of research going on in the diabetic world to show that it is a fantastic material for that population. I'm just going to take you through a case study or a case example of an individual who's had a dynamic assessment, so we can see some of the clinical data that we can get for that individual, and then how does that link in to an orthotic for that person. So here, this individual's walked across the system multiple times. We've captured 6 left and 6 right foot strikes. We're not just relying on one, which is important. We're able to average all of that clean data. So we've got a white line, which is the dynamic center of pressure. We can see that this individual, their right heel really collapses in when they load. They've also got hallux rigidus on the right side, and we can see peak pressure through metatarsals 1 and 2. Again, quite difficult to see peak pressures when we're just visually looking at someone, so this is here to complement us and to give us more data to base our decisions on. We can look at the 3D analysis, which is now looking at the peak pressure areas through the dynamic foot strike. Now, quite clearly, we can see on the right side, we've got a much greater medial load. If we look at the big toe, for instance, we've got a huge asymmetry. So when there are these asymmetries, very easy to highlight and very easy to talk about. The impulse screen is looking at pressure over time. So now not only can we look at high pressure areas, we can see, well, how long is that high pressure area in contact with the ground? Because if we're multiplying force over time, it's going to combine. So we can see now, particularly these areas, especially when working with diabetic patients, these are key areas to look to offset that load to minimize the risk of ulcerations. But really, we want to try and minimize this in all of our clients. It's very important in a clinical base to keep it very visual so we're not confusing the client, or the patient, sorry. So these first 3 screens are all very visual, quite easy to interpret and talk about. We are able to go to that next level of in-depth clinical. For you guys, as clinicians, very powerful. You can go to the finite details. I can see the exact pressure going through all the different points of the foot. And a really useful screen is called the risk analysis. So this is based on a large military study. It's taking into account all of the dynamic data for that individual. So it will look at the medial to lateral loading in the rear foot, midfoot, and forefoot. It will look at the timings, peak pressures, and then based on all of that dynamic data, it will suggest or quantify the risk of lower limb injury for that individual. So again, a very useful screen to talk about with patients, but again, this may highlight something that visually you've just not picked up, because it could be something very minor. So from a Footscan perspective, lots of accurate data, and again, I've obviously breezed through that because of time restrictions, but if you wanted to go through that and any more data and see it live and how that all works, then by all means come and have a look. So the exciting part, Footscan's been around for over 20 years as a clinical diagnostic tool, progressed over that time greatly, but now built within the software, we're able to actually predict some of the key parameters based on their data. And again, this is based on a scientific foot model, and it will take into account the left and right foot individually. So these are just a few of the parameters which are suggested for that individual. And as I said at the start, you've not got to go exactly with what it says. If you think, well, actually, I think this would be better for this patient or this application, you've got total control, but it's there to complement and assist your decision making. So for instance, the system knows your weight and the force that goes through the foot. It will suggest the thickness and hardness of a top cover. Stiffness direction is something totally unique to Phits or dynamic 3D printing. We can now start to create a torsional effect within the orthotic shell to start to control pronation or supination, specifically based on just the direction that it's 3D printed. So if the feet are typically pronating or really collapsing in, it tends to print in a positive direction. If we go back to this example, for instance, we can see both feet, the COP is kind of on the medial border of the midline of the foot, more so on the right-hand side. So arguably slightly more pronated in this case. When we get to the predictions for this individual, we can see 10 degrees on the left and 12 degrees on the right. Now that's not a 10-degree rear foot post. This is purely looking at the direction of the print. So what that will do, as a positive direction, these ridges will run through the device. So this will start to minimize pronation and encourage the foot into a more stable supinated position. Oppositely, if you had a very supinated foot with a high lateral load, it would print in a negative direction to limit that supination and encourage the foot to pronate. So we can start to create that effect within the shell rather than having to add on lots of bulk. Hence the weight is very light and the bulk is very low. On the right hand side, another prediction is called localized stiffness. So rather than having an orthotic shell, which is one density, perhaps it's plastic, polyprop or EVA, we actually have 5 varying zones of stiffness in the device, and again, this is specific to that individual's data. If required, so for instance here, we can see on the medial arch, we've got a more rigid area, and again, much easier to show you in the software, but this will give you an idea. If you wanted to change any part of that, perhaps you're prescribing for a tennis player who does lots of lateral side-to-side motion, and they can really benefit from a more rigid lateral border, you can simply increase the rigidity of that. You won't see it physically on the device, but we can be flexible in some parts and rigid in others to start to guide that foot as we want it. And the bottom one as well, heel wedge or rear foot posting as it's otherwise known. This will take the first 10 to 15% of the dynamic roll-off. So again, going back to this case, we can see quite clearly that the right heel rolls in. And if we're visually assessing someone with our manual assessment, rear foot post is an educated guess. Whether we like that phrase or not, it's an educated guess. So again, allowing this to kind of complement our decision making is very useful. So we can see in this case, it's suggesting a 2-degree medial wedge on that rear foot. As I said, if you wanted to go 3 degrees, it's your decision as a clinician. So since we launched Phits in the UK in March last year, we've got over 80 clinics on board prescribing Phits 3D printed orthotics. So it's still quite early days, but we've got some really top end, very respected clinicians on board with fantastic results throughout. Again, I'm not going to read these out, but it will give you an idea of the type of people that we've got using it. So we've got lots of success in orthotists, podiatrists, we've got some really nice multidisciplinary clinics as well who combine podiatry and physiotherapy, for instance, so they're looking at the whole body as well as a whole, which is really important. And we've got people who've been doing orthotics for 30, 40 years. This individual at the bottom, over 30 years, so very experienced in what she does, and safely can say she's never experienced a foot orthotic like it. It's so specific to her needs that she's fallen in love with it. Ian, the chap in the middle, some of you guys might have spoken to him at the show. He works for Pace Rehabilitation, which are the UK's leading independent amputee services. And Ian's been using 3D printed orthotics for around 15 months now with fantastic results. So again, I'm sure he'll be more than happy to have an open conversation with you and discuss his outcomes. Sorry about that, Ian, if you get mobbed now. And in terms of patients, so another way to look at this, orthotics aren't just for someone who necessarily has a bad foot pain or a deformed foot. We can look at it in a totally different way. They can actually start to minimize the risk of injury, which is really important when we're looking at athletes or sportsmen. And in some cases, they act as a measure to enhance performance. So we have very sport-specific devices as well, like a cycling orthotic, and we start to improve the efficiency of the power through the pedals, for instance. So there's lots of different applications of orthotics. It's not just necessarily because someone's in pain. And we've got fantastic feedback, even at the top end. We've got marathon world record holders, we've got Olympians, we've got British cycling, so across the board. And this is absolutely not just saying that these are for sport people, these are for anyone. And obviously, you guys, a big population for you is the 50 plus who are in pain, who need some control and need some support. Oh, too far. Okay, so I guess that's a brief insight into the clinical applications of Footscan. Hopefully you can see some value in that. And the way things are starting to move, you will start to see 3D print everywhere. Give it 5 years, this room will be full of it. If you want to lead the way, that's the message we're starting to push. The future is now, it's here, it's available. Come and have a chat with us. And if you've got any questions, we're totally transparent and happy to answer any of those. So I'd like to invite you over to the stand rather than shout at me from miles away so I can take you through it on a more one-to-one basis. So thank you very much for your time and enjoy the rest of your day. Lastly, I'd just like to say many thanks for Tony for putting on such a fantastic event. Done a really good job, so not a round of applause for me, a round of applause for Tony, please. Thank you.